my beautiful listeners, welcome again to class. It is your favorite channel, BFN112 Mathematics class. And today we are going to be learning how we can use Cramer's rule in solving some linear equations, simultaneous linear equation, to be precise. Right? And please, my BFN students, know that this is a very, very simple method to which you can use in solving simultaneous equations. Naturally, we have different methods. We have eliminating method, we have substitution method, we have graphical method. Now, the matrix method, which involves the Cramer's rule, is another method that you can use in solving three variable simultaneous equation, or as the case may be, two variables simultaneous equation. So let's see, we're going to be solving two questions today, two examples. And I bet you with these two examples, you will be able to solve other questions using Cramer's rule. So let's begin the class. Example 1 says, using Cramer's rule, solve for x and y. Solve for x and y in 4x plus 2y equal to 6 and 2x plus 2y equal to 4. This is what we are solving. 4x plus 2y equal to 6 and 2x plus 2y equal to 4. Normally, this is a simultaneous equation because it involves two variables, x and y, which we are going to be getting their answers simultaneously. It means either we get x first before we get y, or we get y first before we get x. Alright, let's begin. How do you apply Cramer's rule in solving this kind of question? It is steps. It is what? Steps. You don't just go and start. You need steps. And what are the steps? The first step is this. You will notice that in this question given, there's nothing that is matrix about this question. There's no sign, there's no nothing, it's just there. It's just an equation. So you have to first of all bring this equation into a matrix what? Format. And how do we do that? Watch. It becomes, first of all, the coefficient of each variable here will come first, which are 4, 2, 2, 2. Yes, then you close. That's the first thing you do. The coefficients. Meaning, if there was no number here, what would I give here? 1. Because y is carrying an invisible coefficient of 1. But actually we have 2. Now the next column here talks about the variables in the question. And what are the variables in this question? X and y. So here becomes x and here becomes y. Alright? Step by step. Equal to. Now my last column here talks about the constants, which includes what? 6 and 4. Alright, 6 and 4. So you see now, we have finally brought out this equation to look like matrix. This is now in a matrix form. So now that I've gotten this, what do we do next? Let's go. First of all, don't forget we're looking for the value of x and we're looking for the value of y. The value of x and the value of y. So the first one we're going to look at for is our change. But before I begin, what are the formulas for x and what are the formulas for solving y? The formula for solving x is change in x over change. And the formula for solving y is change in y over change. Are you with me? Now, what is change? Change is finding the what? The determinant of the coefficients of the variables, which include 4, 2, 2, and 4. We look for the determinants of here. So let's get the determinant of what now? Let's look for change first. Now, like I said, change means looking for the determinant of this guy, which is what? 4, 2, 2, 2. Now, class, let us look for the determinants. 4 times 2, 8. 2 times 2, 4. So, class, what is 8 minus 4? 4. That is the value for change. Nothing more. So next, what are we looking for, class, now? Change in x. How do you get change in x? This is what you do. Watch. Look, 4, 2. Look at me. 4, 2 was gotten from here. So it means 4, 2 belongs to x. 2 belongs to y. What does that mean? When you say change in x, it means remove this 4 2 which belongs to x and put your constant there. That's it. Replace it. That's going to change in what? In x. So if I want to write it now, instead of me writing 4 2, what would I write now? 6 and 4, because I've changed it. Then what will remain here now? 2 and 2. Again, I'll look for the determinant. 6 times 2, 12. 4 times 2, 8. 12 minus 8, 4. That is our change in x. Next, change in y. What do you think change in y will be now? This column belongs to y. Remove it and give your constant. So here it becomes 4 2. Then here it becomes 6 and 4. Again, let's look for the determinant. 4 times 4, 16. 2 times 6, 12. 16 minus 12, 4. Now that we have gotten the values of change in x and change in y, now we can get the values of x and y. Now, like I said, the formula for x is change in x over change. So if I should substitute, when I solve for change in x, I got 4. When we solve for change, I got 4. So class, what is 4 divided by 4? 1. X is 1. Let's go for y. Formula for y is change in y over change. When I solve for change in y, I got 4. When I solve for change, I got 4. What is 4 divided by 4? 1. Therefore, x is 1, y is 1. That is how you solve using Cramer's rule. X is 1 and y is y. As well, if you use the eliminating method or if you use substitution method, you're also going to get the values for x and y as 1 and 1. Okay. Now, next, the question we're going to be looking at now is the one that involves 3 variables. 3 variables. 3 variables. Okay. If you are just joining us, you're welcome to class again. Don't forget to subscribe. Make sure your notification button is on so you always get notified when I give new videos. All right. Example number 2. Example number 2. Now, in example number 2, we are going to be using Cramer's rule. I'm coming. Let me get a question that we're going to be solving. All right. We are going to be using Cramer's rule to solve this question. 4x plus y minus 4z equal to 12. All right. 3x minus 2y plus 2z equal to 3. X plus y plus z equal to 4. Thank you very much. Now, you will notice that this question has 3 equations. Why? It's very simple. Because we have 3 variables. The first example had 2 equations. Why? Because we have 2 variables, x and y. Now, what did I say before? So we're going to do, we have to represent this in a matrix pattern. Now, what did I say we first here now? The coefficients. The numbers that the variables are carrying. So let's go. The first number here is 4. Here we have nothing. So what will be there? 1. Here we have minus 4. Here we have 3. Minus 2. And 2. Here we have 1. 1. And 1. Aha! Now, what did I say in the next column? The variables itself. What are the variables here? X, y, and z. Now, what's the last? The next becomes my what? Constant, which is 12, 3, and 4. We have represented this now in a matrix pattern. So what did I say we do? First of all, we're going to look for change. Then we look for change in x, change in y, and change in z. Then we can get the value of x, y, and z. How did I say you solve for change? Finding the determinant of this one without substituting nothing. So let's look for change. Now, change now becomes the determinant of, tell me. Alright? The determinant of 4, 1 minus 4, 3 minus 2, 2, 1, 1, 1. I gave you a better way or a shorter way for solving the determinant by rewriting this first two column here to make it 5. So here becomes 4, 3, 1, and here becomes 1 minus 2, 1. So let's close. Now, without wasting time, let us solve. The first three diagonal elements we have here is 4 times minus 2 times 1. And 4 times minus 2 times 1 gives us minus 8 plus. The next three diagonal elements are 1 times 2 times 1, which is 2. And minus 4 times 3 gives you minus 12. And minus 12 times 1 also gives us minus 12. Right. Minus. Now from here now we have 1 times 3 times 1 gives us 3. Plus 4 times 2 times 1 gives us 8. Plus minus 4 times minus 2 gives us a positive 8. And 8 times 1 gives us 8. Alright, cross of the board. Now let's proceed. Minus 2, now we have two sides here, plus and minus. So plus times minus gives us minus. So we have minus 2 plus 8, which is minus 6. And minus 6 minus 12, which is minus 18. So I have minus 18 minus. Now 3 plus 8 gives us 11. And 11 plus 8 gives us what? 19. So class, what do we do? Minus 18 minus 19 will give us what? Minus 37. So here it becomes minus 37. Why is it minus 37? Because here means you owe 18 and you owe 19. So how much do you owe? 87. So what sign shows that you are owing? The minus sign. Alright. Now we are done with change. So what are we going to look for now? Change in x. Now change in x simply means this first column here, which belongs to x, we'll take it away and give this what? We'll replace it to our constant. So here it comes 12, 3, and 4. Now we have the rest as 1, minus 2, and 1, minus 4, 2, and 1. Again, using the method we said, replacing these first two columns, we have 12, 3, and 4, and 1, minus 2, and 1. Alright, so let's work with this. 12 multiplied by minus 2 gives us minus 24. Minus 24 times 1 gives us minus 24. Plus 1 times 2 times 4 gives us 8. Minus 4 times 3 times 1 gives us minus 12. Alright, good. Minus 1 times 3 times 1 gives us 3. Plus 12 times 2 times 1 gives us 24. 24 plus minus 4 times minus 2 gives us positive 8, and 8 times 4 gives us 32. Alright, so here becomes plus times minus gives us minus. So now minus 24 plus 8 gives us 16, sorry, minus 16, and minus 16 minus 12 gives us minus 28. Minus 3 plus 24 gives us 27. 27 plus 32 gives us 59. Alright, so now if we work with this, minus 28 minus 59 will give us minus 87. Minus 87, because why? You are owing 28 and you are also owing 59. So how much are you owing together? 87. And what sign will show that you are owing is a minus sign. So let's look for change in y. You know, we have to look for the change of all the variables before we can start solving for the values that they have. Now, change in y now means removing the second one because it has to do with y, and then replacing this with our constant. So here becomes 431. Now my second column now becomes 1234. Also here we have minus 421. All right. So now again repeating the first two columns. First column is 431. Second column is 1234. Yes. So let's go again. 4 times 3 times 1 gives us 12. 12 times 2 times 1 gives us 24. Minus 4 times 3 gives us minus 12. And minus 12 times 4 gives us minus 48. Minus 12 times 3 times 1 gives us 36. Plus 4 times 2 gives us 8. And 8 times 4 gives us 32. Plus minus 4 times 3 gives us minus 12. And minus 12 times 1 gives us minus 12. Alright, good. Now, plus times minus is minus. Plus times minus is minus. So let's see what we're going to get now. 12 plus 24 gives us 36. Alright, now 36 minus 48. 36 minus 48 will give us minus 12. Minus 12. Minus 36 plus 32 gives us 68. And 68 minus 12 gives us what? 56. Now, minus 12 minus 56 gives us minus 68. Because we are owing 12, but you're owing 56. And altogether, you are owing 68. Alright, we have one more, which is change in Z. Change in Z. Now, change in Z simply means now your third column belongs to Z. Take it away and replace this with your constant. So here becomes 4, 3, 1. 1 minus 2, 1 minus 4, 2, 1. Now repeating the first two columns, we have 4, 3, 1. 1 minus 2, 1. Alright. Now let's start. Here becomes okay. Oh, sorry, there was a mistake. We have to what? Change the third column. Now, our third column here now is 12, 3, and 4. So here becomes 12, 3, and 4. Yeah, changes there. You have to substitute it. So now, repeating the first two columns becomes 4, 3, 1. And here becomes 1 minus 2, 1. All right. Sorry for that. Now, without wasting time, let's begin. 4 times minus 2 gives us minus 8. And minus 8 times 4 gives us minus 32. Plus 1 times 3 gives us 3. Times 1 gives us 3. Plus 12 times 3 gives us 36. Times 1 gives us 36. Minus, all right? No, we have to manage the board. Now, from here, 1 times 3 times 4 gives us 12. Plus 4 times 3 times 1 also gives us 12. Plus 12 times minus 2 times 1 gives us minus 24. All right. Now, without wasting time, let's proceed. Now, here becomes minus 32 plus 3 gives us minus 29. And minus 29 plus 36 gives us what? 7. Minus 12 plus 12 gives us 24. Now, plus times minus gives us minus. So, 12 plus 12 gives us 24. 24 minus 24 gives us 0. So, our answer here is what? 7. 7 minus 0 is 7. Alright. So, now, without wasting time, this is what we are going to do. Now that we have gotten change in X, change in Y, change in Z, and we've also gotten change, let us find the values of X, Y, Z. X is equal to change in X over change. Now, when we solve for change in X, we got minus 87. When we solve for change, we got minus 37. Alright, so now a minus should cancel out minus. Okay, now we have 87 and we have 37. What do we have as our answer there? 87 over 37. Because nothing can cancel out. Alright, good. So let's go to Y. Y is change in Y over change. Now, change in Y we got was minus 68. Our change is minus 37. Now when minus returns to us minus, what do we still have here? 68 over 37. You can actually cancel out, right? Good. Now Z. We said change in Z over change. Now change in Z we got 7. And change we got 37, which is the same thing as 7 over 37. So these are the values for X, Y, and Z using Cramer's rule in solving that question that was given. So class, you see, these are the steps you follow when you are applying Cramer's rule in solving simple linear or when you are solving simultaneous equation involving 2 variables or 3 variables. Alright class, we've come to the end of today's teaching. I hope you've learned something new. Till we meet again in our next class, don't forget to subscribe and keep on watching. Alright, bye for now.